The skies over northeast China witnessed yet another secretive step in Beijing's race for air dominance. The J-50, also known by its project name JXDS, took to the air in what is now one of several test flights in its early development phase. This mysterious sixth-generation stealth fighter, developed by the Shenyang Aircraft Corporation, is drawing global attention not just for what it reveals, but also for what it deliberately conceals. Today, we explore everything known and suspected about this cutting-edge aircraft, from its radical tailless design to its hidden flight control technology and what this means for the future of aerial warfare. The J-50, which some sources identify as the JXDS, represents a massive technological leap for China's military aviation. Developed by the Shenyang Aerospace Corporation, the aircraft was most recently observed conducting a test flight near Airframe Plant 112 and the Shenyang Design Bureau, facilities closely associated with advanced fighter design. This test flight follows earlier sightings, including one on April 16th, suggesting that the aircraft is progressing steadily through its flight validation process. At first glance, the J-50 looks unlike anything currently in operational service. It adopts a tailless, stealth-optimized configuration with a lambda-shaped wing and movable wingtips, all aimed at reducing radar cross-section and increasing control authority through non-traditional aerodynamic means. These design choices make one thing clear: China is betting heavily on stealth, sensor fusion, and electronic warfare superiority, even at the expense of traditional dogfighting performance. This bold configuration places the J-50 in the same conceptual lineage as Northrop's B-2 Spirit and B-21 Raider, stealth platforms where survivability and low observability trump all else. But unlike the bombers, this is a fighter, which adds layers of complexity. The tailless configuration used on the J-50 presents both promise and peril. It dramatically lowers radar signature by eliminating vertical control surfaces, which typically reflect radar waves back to the emitter. But this configuration comes with serious aerodynamic drawbacks, namely inherent instability across all three axes: pitch, yaw, and roll. To overcome these challenges, the J-50 must rely on an exceptionally advanced flight control system. This is not a conventional fly-by-wire system like those used on the F-16 or Su-57. Rather, it likely employs an adaptive control system that continuously adjusts the control surfaces in real time to keep the aircraft stable. This is similar to what Northrop achieved with the B-2 and what the US tested as early as the 1970s with the F-17A. Historically, such systems rely heavily on airspeed data and angle of attack sensors to compute necessary flight corrections. However, recent images of the J-50 reveal a curious omission: the lack of a pitot tube on the nose. That's significant because the pitot tube is vital for measuring airspeed. Its absence suggests one of two things. Either the aircraft is using alternative sensor fusion methods to calculate airspeed internally, or this prototype is not designed for full flight envelope testing, meaning multiple prototypes may be in use, each optimized for a specific trial set, like radar signature testing or engine validation. The J-50 is not being designed to mimic the F-16 or the Su-35 in terms of agility or dogfighting prowess. Instead, everything about its design, from the low observable structure to likely integration with long-range sensors and beyond visual range weapons, points toward it being an interceptor or precision strike platform. It might be tasked with penetrating heavily defended airspaces, delivering standoff weapons, and disengaging before the enemy even knows it's there. Like other stealth aircraft, the J-50 is expected to carry its weapons internally. While this has not yet been visually confirmed, the overall fuselage shape and stealth requirements make the inclusion of internal bays almost a certainty. Any external hardpoint use would severely compromise its radar signature, defeating the very purpose of its stealthy design. China's simultaneous development of the J-36, another tailless stealth aircraft, reinforces the theory that the PLA is investing in stealth-centric air dominance for both the PLAF and Plan. This aligns with Beijing's larger doctrinal shift toward anti-access, area denial, A2AD operations, especially in scenarios involving Taiwan or U.S. carrier groups in the Pacific. The current pattern of J-50 sightings suggests that multiple testbeds may exist. Each prototype may be focusing on a different developmental vector. One possibly configured for stealth testing with radar-absorbing coatings, another for flight control validation, and a third for power plant and thrust vectoring trials. This methodical approach matches historical Chinese practices, especially as seen in earlier platforms like the J-20. What's especially intriguing is China's apparent willingness to allow relatively clear images and videos of the J-50 to leak onto social media, a sharp departure from Beijing's traditional secrecy protocols. In a country where such leaks usually result in swift state retaliation, the lack of clampdown could be intentional. Some analysts interpret this as part of China's broader psychological operations, projecting military confidence in an increasingly confrontational Indo-Pacific environment. Whether in the South China Sea, around Taiwan, or along contested air routes in East Asia, China's message is clear. It is not just keeping pace with Western defense technology. The J-50's development trajectory points toward iterative enhancements in propulsion, stealth coatings, and electronic warfare integration. Insiders suggest subsequent prototypes will feature thrust vectoring nozzles derived from the WS-15 engine program, promising greater maneuverability without sacrificing the aircraft's low observable signature. Concurrently, adaptive metasurface panels may be introduced to actively tailor radar absorption across multiple frequency bands, accelerating China's push in next-generation stealth platforms. Behind the scenes, the Shenyang Aircraft Corporation is reportedly collaborating with defense industry leaders to integrate a modular mission bay architecture, allowing rapid recalibration between air superiority strategy and deep strike roles. This modularity not only streamlines maintenance cycles, but also aligns with broader military aviation innovation trends, ensuring the J-50 can evolve alongside emerging threats in contested airspaces. Beyond the cockpit, the J-50 is poised to reshape procurement priorities across Asia and beyond. Its anticipated entry into service could trigger shifts in defense budget allocation among regional powers, spurring accelerated investment in counter-stealth sensor networks and advanced electronic warfare systems. Western aerospace manufacturers are already recalibrating production forecasts for F-18 derivatives and F-35 upgrades in response to the J-50's sensor fusion capabilities and projected operational parameters. At the same time, export markets in the Middle East and Southeast Asia may witness heightened demand for sixth-generation fighter development partnerships, as nations seek to hedge against an escalating race for air dominance. In this way, the J-50 is not merely a technological marvel, but a catalyst for a broader transformation in global defense industry trends. The J-50 is not just another fighter jet, it is a signal, a statement of intent, that China is preparing for the next evolution of air combat. From its radical tailless design to its sophisticated control systems and stealth-first doctrine, this aircraft embodies China's ambition to dominate the air domain through next-generation innovation. Its latest test flight on May 8, 2025, reinforces the fact that development is progressing rapidly. As more prototypes take to the skies and more details emerge, the world will be watching closely, because the future of aerial warfare may very well be flying right now over Shenyang.